Hey guys, in this video I'm going to be looking at some questions from the 2017 Maths GCSE Edexcel exam. This is the first paper. It was a non-calculated paper, and I'll be looking at questions 8, 10, 14, 16, 17 and 22. Please let me know if you'd like me to go through any other questions. These are just the questions that I found most interesting, I guess. So I'm going to start on question 8. Question 8 was about standard form, and it says write 7.97 times 10 to the minus 6 as a normal number. I would just start off, I would just keep it as simple as possible, and I know I need to 10 to the minus 6, that's like 1 over 1 million, so you actually have to divide by a million. So yeah, just keep it as simple as possible. We know we need to divide by a million, and that decimal place is going to move back 6 places. 1, 2, 3, 4, 5, 6. And there's going to be, we need some zeros in there, and that decimal place is going to end up there. So that's going to be 5 zeros before the 7. 0.000000797. And I like to draw the diagram just so I'm making sure I'm getting it correct. So part B, we've got evaluate 2.52 times 10 to the power of 5 divided by 4 times 10 to the minus 3. So we can, when you've got two numbers in standard form and you're dividing them, you can divide the whole numbers and divide the powers of 10, and that kind of makes it a little bit easier to work with. So you can write it like this, and all this does is rearrange that problem in a way to make it easier to solve. So here I can solve 2.52 divided by 5 divided by 4, and 10 to the power of 5 divided by 10 to the minus 3. This is exactly the same thing, just written slightly differently. So what I could do is do this quick division. Now take the decimal point out of there, that means that I'm actually multiplying that number by 100, so I need to divide the answer by 100. So let's do this. 252 divided by 4, well, 4 into 25, that's 6, remainder 1. 4 into 12, that's 3. So that's going to be, remember I have to divide that by 100, so that would be 0.63. And then when we divide indices, we can subtract the powers, so 5 minus 3, well, that will be 5 plus 3, so that's going to be 10 to the power of 8. Now I need to write that in standard form, so I need to make that a number between 1 and 10. So I need to multiply that by 10. So if I multiply that by 10, I'm kind of not taking away, but kind of stealing times 10 from here. So that's going to be 6.3 times 10 to the 7. So I've times that 0.63 by 10, and I've taken 1 away from the index number there. Yeah, so I think it's really worthwhile to learn a few shortcuts with these standard index form problems. Alright, next question I want to go through is 10. So it said expand these brackets, x plus 1, x plus 2, x plus 3. And all you really need to do is just multiply the first brackets and then expand with the last lot of brackets. So yeah, I just thought this was a kind of a nice question. I think it was worth 3 or 4 marks, so I think most people should have been able to get this. So let's expand the first 2 brackets, x squared plus 3x plus 2, and then x plus 3. Then we just need to multiply everything in here by everything in those brackets, so x cubed plus 3x squared plus 3x squared plus 9x plus 2x plus 6 and then simplify. So we've got an x cubed and 6x squared and 11x and 6, and that's our answer. So yeah, a good few simple marks there, I think, but quite a nice, neat question. I like expanding brackets. Next one to go through was 14. Compared to the last question, this is a bit of a doozy. So you've got, the question says the ratio of white shapes to black shapes in a bag is 3 to 7. Of the white shapes, the ratio of white circles to white squares is 4 to 5. Of the black shapes, the ratio of black circles to black squares is 2 to 5. What is the proportion of circles? So we know we have some white shapes and black shapes in a bag. What I would do is just draw out a diagram firstly, just to help me picture what's going on. So let's pretend this is the bag. I've drawn a rectangle because it's easier to see kind of fractions in a rectangle. But let's pretend this is the bag. So I've got the ratio of white shapes to black shapes is 3 to 7. So let's say 3 is about there. Let's say I break that into 10, and that's 3 parts, and that's white. And these are the black shapes here. So I've got the ratio 3 to 7, sorry. Then of the white circles, so the white shapes, I've got 4 to 5 are the ratio of circles to squares, and then the black shapes, I've got 2 to 5 circles to squares. And I want to find the proportion of circles. Where I'd start off with this problem is finding the proportion of circles in each color. So I know that the proportion of white circles 4/9. Now I know that the proportion of white shapes in total in the bag is 3/10. Okay, let's just write that out. So proportion of white shapes equals 3/10. Now I want to find out the fraction of white circles in the total number of shapes, because that's what the final question is asking. And it might not appear immediately obvious, but if I asked you, say, what's a half of a half? You can draw a diagram here. I've got half a pizza. What's a half of half a pizza? You have to split that in half again. That'd be half of a half. And then what is that as a proportion of the whole pizza? It's a quarter. How have you found that? You've actually multiplied those. You've said a half of a half, or a half times a half, is a quarter of the pizza. What does that mean for our question? So I've got the proportion of white circles and the proportion of white shapes. So I want to find out 4/9 of 3/10 to get the proportion of white circles to total shapes. So I'm going to do 4/9 multiplied by 3/10 to get the proportion of white circles, and then I need to do the black circles, and then I can add those together to get the answer. So here I'm going to do some cancelling. Before I figure it out, I like to do my cancelling first, and then, so that's going to be 2/15. So that's a proportion of white circles. Now I need to figure out, do the same thing for black. So proportion of white circles, proportion of black circles, proportion of black circles, that would be 2 over 7. And then, so the proportion of black shapes is 7 over 10, so proportion of black circles to total shapes is going to be 2/7. So I want to find out 2/7 of 7/10. 2/7 of 7/10. And we can do some cancelling again, so that's the 7s are going to cancel. 2 and 5, well that's actually turned out really nicely. That's going to be 1/5. So 2/7 of 7/10 is 1/5. So the proportion of black circles to total shapes is 1 over 5. Proportion of white circles to total shapes is 2 over 5. So the proportion of circles, I just need to add those together. Proportion of circles equals 2 over 15 plus 1/5, because these are out of the total. These are fractions of the total shapes in the bag, not out of their individual colors. So I can add them together. This is going to be, well, times this by 3, so 2 over 15 plus 3 over 15, so 5 over 15 is going to be 1/3. So your answer, proportion of circles is 1/3 in the bag. Next one, I like this question too, nice and neat. Again, if you can see the process, it's an easy few marks in this exam. So we need to prove that n squared minus 2 minus n minus 2 all squared is an even number. Now, so we need to show that in the form. So any even number can be written in the form 2k. So n squared minus 2 minus 2 squared. That's going to be n squared minus 2 minus, let's expand those brackets out, n squared minus 4n minus plus 4. And then that's going to be n squared minus 2 minus, now that minus has to be expanded throughout all of those terms, so that's going to be a minus n squared plus a 4n minus a 4. And then this is going to be, and then we just need to simplify it, so n squared minus n squared. Then I've got a 4n minus 2 minus 4 is going to be minus 6. That factorize that, so that's 2n minus 3. And I've got that in the form 2k, so that must be, therefore, must be even. And that's what we really need to do for that question. Next one, tree diagrams. It seems to be that there's always a tree diagram in these exams. Kind of counterintuitive questions, I guess, or probability questions. Yeah, they're popular with examiners. So there are excuse me, there are 7 green counters and 2 blue counters. If Abdullah chooses 2 at random, work out the probability that he chooses 1 each. Now it doesn't actually say whether he puts the counters back in the bag or just keeps them out of the bag. But it doesn't, usually you assume, if it doesn't say he puts them back in, you assume that he doesn't replace them. So we're going to assume without replacement here. Okay, so let's start our green diagram. This is going to be our first pick here. Green diagram, did I say tree diagram? I meant first pick and second pick. And we've got green and we've got blue. and then we can pick green and blue again, or green and blue again. So these are all of our probabilities. Okay, so we've got 4 possible outcomes. So the probability of picking green first is 7 over 9. There's 9 total counters, 7 of those are green, so it's 7 out of 9 chance of picking a green one, and 2 out of 9 chance of picking blue. Then if he picks a green again, well, he's already picked a green out, so there's 6 green left in the bag, and there's 8 counters in total, so that's going to be 6 over 8 chance of picking a green again. And then he's got 2 blue counters, because he's picked a green. There's still 2 blue left, but there's 8 counters, so that's going to be 2 over 8 for the probability of picking a blue. Then, I should have used different colors for this. And then a green, so he's picked a blue the first time, it's 2 over 9. And then picking a green, so there's still 7 greens left in the bag, so that's going to be 7 over 8. And then picking a blue again, that's going to be 1 over 8. And then we need to figure out the probabilities of these things. So the probability of green and then blue. So we need to figure out the probability he chooses one of each. So we're looking at which sections. We're looking at this one and then this one, or this one and that one. So I'm looking at the probability of green, blue. Well, I need to multiply those probabilities together because we've got 7 over 9 and then 2 over 8. So 7 over 9 times 2 over 8 is going to be 14 over, I could have simplified that. Over 72, which would be 7 over 36. Cool. Then I've got the probability of blue then green. Well, it's 2 over 9 and 7 over 8. It's still going to give you the same thing. You could rearrange that to be 2 over 9 and 7 over 8. It's going to just be 7 over 36. Then I just need the probability of green, blue, or BG. Green and blue, or blue, green. And, well, when we're saying or, we can add those fractions, so it's going to be 7 over 36 plus 7 over 36. And that's going to be 14 over 36. Simplify that down to 7 over 18. Okay. So 7 over 18 is our answer there. And now we get to question 22. This was the last question on the paper, and it's quite a nice question. It needs a bit of problem solving technique in order to see how to get to the solution. The only thing you need is the cosine rule. So the cosine rule looks like this. A squared equals b squared plus c squared minus 2 lots of bc cosine a. And so let's have a look at the question. So it says the parallelograms ABEF I gave this diagram as well, and BCDE are congruent, and PB and BQ have a length of 10. So first thing you could do is draw a line and label those 10 units each. Okay. All right. So let's talk about some problem solving technique here. So it says prove that cosine of PBQ equals 1 minus 2 minus root 3 over 200 x squared. it doesn't say use the cosine rule, but when you see the cosine of PBQ, then hopefully you're thinking, I need the cosine rule here. Let's see if we can use that somehow. And also, we are going to need, now everybody knew that the cosine rule could be in there in the exam paper, so that shouldn't have been a shock to anyone. Also, we knew that people might need to know some trig values, so most people would have been memorizing these types of triangles. That gives values for common angles, and using SOHCAHTOA, we know that the cosine of 30 is going to be the adjacent over the hypotenuse, so that would be root 3 on 2. So we knew that that could have come up in the exam, and that's all we need for this problem, which is, I think, is pretty cool. And then we need to have a look and see, well, how can we somehow come up with a relationship between this angle PBQ and this angle ABC? Because we're told angle ABC is 30, but we don't know what this angle PBQ is. And this is what I love about mathematics, the kind of the creative kind of parts, questions that engage that side of the brain that you need kind of a bit of problem solving, ability, or ability is the wrong word, but you know, you can sit down and you can kind of think about it a bit. So what you needed to see here was that there's two triangles in this diagram, and they're related by a common side. Because we know these two parallelograms are congruent, we know that these sides must be parallel, and therefore we know these lengths are equal, PB and BQ. Therefore, this side in here, AC, gives you one triangle, ABC, and if we draw that same line, those two lines PQ and AC must be parallel, and they must be equal. Therefore, we've got two triangles, ABC and PBQ, with a common side. And that was, I guess, that was probably the starting point that was trickiest to see. Or in my opinion, that was the trickiest part of this problem. The rest is kind of following kind of a pattern, a problem-solving pattern that people would have been familiar with. So I'm going to draw out those two triangles and then see how we can start solving this problem. Okay, I guess the next step, we know that AC and PQ are equal. We need to first find a rule, an expression for AC in terms of x, so and cosine of angle B. So let's just see what we can plug into this cosine formula. So let's see, a squared equals b squared plus c squared minus 2bc cosine A. Well, here, this is the side A, so we're going to say AC equals b squared. B is x and c is x, and so we've got two lots of x times x, and then cosine angle A is 30, so we've got cosine of 30. So AC is going to be 2 lots of x squared minus 2 lots of x squared. Now cosine 30, remember I was talking about this triangle. Cosine of 30 is root 3 over 2, so we can plug that into this formula. And so we've got that length AC equals 2x squared minus 2x squared root 3 on 2. Okay, and then I might factorize this. Actually, we can cancel some 2's out, so there go the 2's. And then factorize the x squared out, so we've got x squared 2 minus root 3. So I've got a nice neat expression for AC, and I know that AC equals PQ, so I can say that line AC equals line PQ equals x squared 2 minus root 3, and that's an important line to put in just to show you working out. Okay, so let's get back up here. Now we need to relate this length to the angle, so, or in other words, we need to relate this angle to x, and the reason we've got these two triangles is to relate the x in this angle 30 to this angle PBQ, and by getting that expression for that length in x, that means that we can now use that expression in the cosine rule for this triangle. So let's so for this one, just going to write the cosine rule out again, just to be nice and clear. If you didn't, I wouldn't suggest going into this much detail in your working out if you didn't have to, because you should be kind of conserving time, but just to kind of, for the purpose of showing my working out here in this video, I'll write it again. So when we're using the cosine rule for this triangle, we've got A is going to be PQ, so PQ equals, now I know these side lengths are going to be 10, so B is 10 and C is 10, and then I've got two lots of 10 times 10, and then cosine of A is cosine PBQ. Okay, so I've got that cosine PBQ, and that's what is going to come up in my proof, so that's a good sign. Now I have an expression for PQ, which is x squared 2 minus root 3, so I'm going to plug that into the equation and simplify this a little bit. So that's going to be 200 minus 200 cosine PBQ. Okay, this is looking quite good actually. This is looking like we're going to be able to get to this right hand side. So I'm going to flip this around and take that 200 from the other side. So this is going to be minus 200 cosine PBQ equals x squared 2 minus root 3 minus 200. And then I need to divide this by minus 200. So because I'm dividing by a negative number, then the signs on this side change. So this is going to be cosine of PBQ equals, so that sign is going to change, so 200 divided by 200, that would be 1, and the negatives cancel out, and then this is a positive now, so that's going to change to a negative, and then so I'm going to have x squared 2 minus root 3 divided by 200. And that looks almost exactly the same as the right hand side. I just need to put the x squared at the front there, so, and I can do that, that's the same thing. So if I move that to the front, it's still going to be the same, still multiplying by x squared. So the cosine of PBQ equals 1 minus 2 minus root 3 over 200 x squared, and that equals the right hand side. So so that's question 22. I hope that's been helpful. Please let me know if there's any other questions you'd like me to go over, and I'll see you next time. Bye.